Look at this picture, filled with stars and galaxies, except there's a huge void in the middle, commonly known as the Portese void. It is a vast empty region with almost nothing inside. Wrong. This image is often mistitled as the Portese void. In reality, it is something within the Milky Way. You see, our galaxy is more than just a collection of stars that revolve around the center. There are stars with random motions, some moving at much higher speeds. There are rogue planets, globular clusters, stellar nurseries, stellar remnants, nebulae, gases and dust all scattered around the center. The center of this barred spiral, the spherical bulge, is the brightest part of our galaxy, although it harbors its darkest and biggest entity, a supermassive black hole. Discovered as a radio source 50 years ago, this dark heart of the Milky Way is about 50 million kilometers wide and as massive as 4 million suns. And basically everything in the galaxy revolves around it. But it's not the black hole that's holding the galaxy together. It's the combined efforts of everything that's in here, including things we can't see. Among the things we can see though are stars. The bright region around Sag A is due to a large number of stars being present there. They are found in groups known as globular clusters. A globular cluster is a spherical collection of stars bound by gravity. They can contain thousands or even millions of stars. If we were to be on a planet within the globular cluster, the night sky would look something like this. A result of the high density of stars in these clusters, although it would be pretty dangerous for a planet to be between so many massive objects who can heavily disturb its orbit. An interesting fact here is that globular clusters are part of a subsystem of the Milky Way in which gravity is counted not by revolving around the center, but through random motions. An example would be a cluster falling towards the center, then coming out on the other side and then falling back in. We belong to the other subsystem, the one where objects revolve around the galaxy. It takes us about 230 million years to complete one orbit around the Milky Way. That's one galactic year. But not every star has a well-defined orbit, and not every planet is bound to a star. Runaway stars move through space at much higher velocity than the others. They might have been accelerated due to a high gravitational interaction or an explosion. Some hypervelocity stars are so fast they might escape the galaxy. Note that when I say stars, I don't just mean regular stars but also dead ones. White dwarfs, neutron stars and black holes also exhibit these random motions. It's objects like this that make the Milky Way more chaotic. They can collide with other objects, even us, but the chances are near zero. There are also rogue planets. These lonely entities roam around the interstellar space, not bound to any parent star. They are like orphans. It's possible that they were once part of a star system but then got ejected, or they formed outside of a system to begin with. On larger scales, stars are essentially point objects, with large spaces between them. But this interstellar space isn't just vacuum. The galaxy is filled with gas and dust. Although compared to Earth's atmosphere, which is a quintillion times denser, it does feel like vacuum. But on a large scale, compared to intergalactic space, the interstellar medium does act like a gas. They make observations along the galactic plane much more difficult. Looking outside through this 1,000 light years thick disk is practically impossible. It's mostly hydrogen. There's some helium too, and very small traces of other simple elements. The simplest of them all is the atomic hydrogen, and that's what a lot of these clouds contain. These H1 clouds can be cold as well as warm, the warm ones being 100 times lighter. These hydrogen atoms can be ionized by ultraviolet radiations from a newly formed star nearby, forming H2 regions. These are thousands of kelvins hot. The hottest and lightest ones though are the coronal gases emerging from supernova explosions, reaching millions of kelvins. Meanwhile, the coldest and heaviest are the molecular clouds. These interstellar clouds can sometimes form large structures called nebulae, of which there are multiple types. Diffuse nebulae are large extending clouds with no specific boundaries. Planetary nebulae can form from the expanding outer layers of a dying star. A nebula can also be a remnant of a supernova explosion. One interesting type is a dark nebula, a clump of black clouds so dense that it completely hides what's behind it. The picture at the beginning is exactly that, a dark nebula known as Barnard 68. Nebulae can be thought of as stellar nurseries, as they often contain regions that can collapse under their own gravity and form new stars. The pillars in the Eagle Nebula would be an example. Those areas are in the process of creating new stars, which is why they're famously called the Pillars of Creation. These are cosmic rays, simple hydrogen and helium nuclei that have been accelerated so much that they travel through the galaxy at almost the speed of light. A lot of them spiral around the galaxy's magnetic field, which itself is along its spiral arms. It's not very strong though. The field on Earth is stronger by a factor of about 100,000, which is also how wide the Milky Way is in light years. But that's not where it ends. 25,000 light years on either side of the disk, we find two gigantic bubbles of high energy gamma ray emissions. Their origin though is unclear. It could be the aftermath of either the black hole consuming a humongous amount of matter, or a large-scale star formation taking place at the center. Then there's the stellar halo surrounding it, consisting mainly of old stars and globular clusters. This halo is barely visible because of its extremely low density. And all of this combined accounts for a grand total of 5% of the Milky Way. Yes, most of the galaxy, most of the stuff that holds it together, exists in a form that's completely hidden from us. Hence why we call it dark matter. That's how big it should be. We know it's there because something has to be holding it together. We can't detect it apart from its gravitational effect. It does not interact with light or any electromagnetic radiation. Dark matter is one of the biggest mysteries of the universe. And this is what it would look like if we could see everything: the disk, the bulge, the bubbles, the halo, and the dark matter. This is the Milky Way.